Hello everyone, I am Poornavalli, Assistant Professor, Department of Mathematics in SNS College of Technology. In this video, we are going to see what is conditional probability and few more problems using conditional probability. The conditional probability of an event B, assuming that the event A has happened, is defined as probability of B given A is equal to probability of A intersection B divided by probability of A, provided that probability of A is not equal to 0. So similarly, we can get the conditional probability of A given B is equal to probability of A intersection B divided by probability of B, provided probability of B is non-zero. So here we have one theorem that if A and B are two events that are independent, we have to prove that A complement and B are independent, and A and B complement are independent, and also we have to prove A complement and B complement are independent. So it is enough to prove as A and B are independent that P probability of A intersection B is equal to probability of A into probability of B. So here we have to prove A complement and B are independent. It is enough to prove probability of A complement intersection B is equal to probability of A complement into probability of B. So for that, we are considering B is equal to A intersection B union A complement intersection B. So taking probability of both sides, probability of B is equal to probability of A intersection B union A complement intersection B. So we know that probability of one event union another event is equal to probability of event first event plus probability of another event. So that we can get probability of B is equal to probability of A intersection B plus probability of A complement intersection B. So from this we can get probability of A complement intersection B is equal to probability of B minus probability of A intersection B. So we know that probability of A intersection B as probability of A into probability of B. So from these two terms, we can take probability of B as common. So that first term will be 1 minus second term will be probability of A. So 1 minus probability of A is probability of A complement. So from this we can conclude that A complement and B are independent. So likewise we have to prove A and B complement are independent. So it is enough to prove probability of A intersection B complement is probability of A into probability of B. For that we have to consider A is equal to A intersection B complement union A intersection B. So taking probability on both sides, probability of A is equal to probability of A intersection B complement union A intersection B. So probability of one event union probability of another event is equal to probability of that event plus probability of another event. So from this we can get probability of A intersection B complement is equal to probability of A into probability of B complement. Hence we can conclude that A and B complement are independent. So our third subdivision is we have to prove A complement and B complement are independent. For that we have to prove property of A complement intersection B complement is equal to property of A complement into property of B complement. For that we have to consider probability of A complement intersection B complement is equal to probability of A union B the whole complement. From that we can write probability of A union B complement as 1 minus probability of A union B. So A union B can be written as probability of A plus probability of B minus probability of A intersection B. So here probability of A intersection B can be written as probability of A into probability of B. So I'm taking this minus to three terms. So 1 minus probability of A minus probability of B plus probability of A into probability of B will get. So combining this two, I get probability of A complement. So taking common term in this two term, we'll get probability of B into 1 minus probability of A. So we know that 1 minus probability of A will be a probability of A complement. So from this we can take a common term, that is probability of A complement. So this first term will be 1 minus the second term will be probability of B. So we know that 1 minus probability of B will be probability of B complement. So we'll get probability of A complement intersection B complement is equal to probability of A complement into probability of B complement. Hence we can conclude that A complement and B complement are independent.